Okay, we have two topics to do today, and you're going to get a lot of time to actually get them done in class. But we've got to keep a good pace. Yeah, otherwise we're going to struggle. Okay, so we're not going to cover all the notes here, but we are going to cover some of the important stuff. So I made these notes 5 years ago, and again, you guys are kind of like my guinea pig class. I'll tell you right now. First two times I covered this class, I covered this much content, and we're going to cover instead of this much content, we're going to cover this much. There's a few pieces that need to get skimmed off. There's a few pieces that really are not that important. And I've learned that after teaching trigonometry for a number of years. So this one right here, we're not going to do it. It's really not that important. If we need to learn it, we can do it some other time. So those two pieces are gone. Okay? I used to teach them. It's really not that big of a deal. Having taught the college trigonometry for 5 years now, we've not done a single problem like that. So if we need to get to that at some point, we can. If we need to backtrack, we will. This is super important. We're going to cover two ideas today that are of the utmost importance. Number one, sketching angles in their standard position. And number two, finding coterminal angles. Your book has very minimal. All right. An angle in standard position. Here is what we consider. We need to define this as standard position would be this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now I just went around once. Is there a time where something happens in life where you ever go around more than once in a circle? Yeah. For example, you know, in the dunk contest, 360 slam dunk, that means that you did a full turn before you dunk the basketball. There's guys now, they'll do a full 540. Okay. So they'll actually take off with their back, the basket, and they'll do a half a turn and another full one. Okay. So, people will do that. Okay. So 540, whatever. Or they'll approach forward, but they'll do a full turn and a half, so they'll end up doing a reverse jam. So whatever. So we want to sketch it in standard position. You have to do this. Which quadrant, 1, 2, 3, or 4, will 42 degrees lie in? 1. And so when you draw it, you have to have the initial side is always along the x-axis right there. The terminal side will be in the quadrant that you land, say there. And then you have to draw this to show how you rotated. I rotated 42 degrees in that direction. Does that make sense? So let's try one that's different. What do you think we do if it's a negative angle? We rotate the other direction. So you tell me when I've reached negative 90. Right? Negative 90. So which quadrant will negative 113 bring me to? The third quadrant. I've traveled two quadrants, but this is, I'm sorry, I didn't label them out. 1, 2, 3, and fourth quadrant. So that makes sense. I'll end up in this quadrant. So I sketch the angle, and it doesn't have to be exact, but now I draw the arrow this way because that would be a negative rotation. As opposed to a positive rotation, right? So it's the blue one that we want, not the green one. Does that make sense? Okay. How is letter C different from letters A and B? we're in radians, correct? So you got two options. You can either think about it in radians or you can convert it. If we wanted to convert this to degrees, how would we do it? We would multiply by 180 divided by pi. Pi's cancel, and you get 240 degrees. Which quadrant will that place me in? It will place me in the third quadrant. So I draw this side. And I draw the way in which I rotated. Now this is a little bit more challenging, folks. How about negative 4.6? Is that a radian measurement or is that a degree measurement? Why do you say radian measurement? Because there's no degree sign. So even though it doesn't have a pi in it, it's still a radian measurement. So let's do this. Let's convert it. Negative 4.6 times 180 divided by pi. Let's see what we get. Negative 4.6 times 180 divided by pi, and I get negative 263. So I'm going to start here. Which way do I rotate? Do I rotate going up or rotate going down? Going down, and this would be negative 90, right? This would be negative 270, and this would be negative 360. So just before 270, so which quadrant is that? Second quadrant, right there. So that's my rotation. I have to draw the arrow to represent the rotation. And finally, what's different about the last one? It goes around more than once. And so we draw it that way, folks. Tell me, how much further past 360 does it go? How many degrees past 360? 60. So which quadrant will I end up in? The first quadrant. Here's my initial side, and I go around 90, 180, 270, 360, and then another 60 degrees at 420. So that's how you show it. You go around more than once like that. And that's the way you need to draw it. Does that make sense? We're going to pause the video and practice that. Okay, so this is your second assignment, coterminal angles. They are angles whose terminal side is in the same position. We're going to take an angle. How about 110? Does that sound okay with you? Which quadrant is 110? 2. I'm going to find two more angles. One that's positive, one that's negative. That's coterminal. Meaning if I sketched it, it would look the same except for the rotation. Okay? It's very simple. The way that we find them is we do one of two things. We either add 360 or 2 pi. Whoop. 360 is the same as 2 pi, or we subtract 360 or subtract 2 pi. Okay? So, if I add 360 to 110, will that give me a positive result or a negative result? Positive. And so if we have an angle that's in the 110 position, okay, and we go around 110 degrees to get to that spot, where will I end up if I go around 360 more? Same spot, right? If I go from right here and then 360 more, I'll end up right at that spot. But that green angle that I showed there is not 110 degrees. It is 110 plus what? And so 470 degrees is coterminal with 110 degrees. Does that make sense? There's an infinite number of coterminal angles. You are simply going to find one that's positive and one that's negative. Now, I'm going to sketch another 110-degree angle, but I'm now going to draw it this way. Is that a positive angle measurement or a negative angle measurement? That's a negative angle measurement. Okay? And so here I'll take 100 and I will minus 360. Whoops, sorry. I was looking at the first problem. 110 minus 360, and we get negative 250. So two angles are coterminal are 470 and negative 250. Got the idea? Okay, let's do a couple together. Let's do number 4. Yes, you need to sketch the rotation for each one. Okay, so negative 200. What quadrant does that put me in? Very good. Negative 200 will bring me back negative 90, negative 180, and then a little bit more. So that's negative 200. Now, let's add 360 to it. What's negative 200 plus 360? 160. So that's going to be in the same position, isn't it? How do I show it differently with my drawing? Yeah, I rotate like this. And then let's subtract 360. Negative 200 minus 360 is negative 560 degrees. Same position. This is coterminal. Yeah, which way? Do I go down or do I go up? I go down and I go all the way around once and then a little bit more, right? Okay. So I've shown you a positive one for 110. I've shown you a negative one for negative 560. Now flip it over. I want to show you with the radians. For these, you may not convert them to degrees. On the test, there's going to be points where you're going to be allowed to convert back and forth. But for this part, I'll be expecting you to leave it in terms of pi. So let's look at 5 pi over 4. If you need a reference angle in order to, if you need to convert it just to get an idea of where it is, that's fine. But let me show you again how we do it. This is 4 pi over 4. So what is this right here? 2 pi over 4. So this is 6 pi over 4. And all the way around would be 8 pi over 4. So where is 5 pi over 4? Quadrant 3. Very good. So I didn't have to convert it. The conversion is 225, but I didn't have to do that. I could just look at it and, work with the fractions and find out where I am. Now, instead of adding 360, I will add what? What's the same as 360 in radians? 2 pi. So 5 pi over 4 plus 2 pi. Well, I need to have common denominators, right? So instead of 2 pi over 1, I have 8 pi over 4. And I get 13 pi over 4. I will have the same quadrant. How do I show the difference in the angle? How do I make it different than that one? This one is around more than once, isn't it? One whole rotation would be 8 pi over 4. I went around 13 pi over 4. And then for my next one, I will take 5 pi over 4, and instead of adding 2 pi, I will subtract 2 pi. And I need common denominators, so instead of subtracting 2 pi, I subtract 8 pi over 4. What's 5 pi over 4 minus 8 pi over 4? Negative 3 pi over 4. So will my rotation be going up or down? See the difference? We have to be able to rotate properly. So that's what you need to work on. Please keep up with your homework. I'm going to tell you guys just a warning. We're going to get through this first unit pretty quick. My guess is we'll be ready for a test next week, Friday. Oh, we have MEA. No, we won't be ready by next week, Wednesday. So when we get back from MEA.